The goal of this experiment is to fully separate a 1-to-1 mixture of acetone and 2-propanol via fractional distillation. The solution will be separated into 3 fractions based on temperature, and the fractions will be analyzed via gas chromatography, or GC. Before starting, protective equipment such as safe lab attire, goggles, and gloves are mandatory. This lab is similar to simple distillation, but with a small change in the apparatus. To begin the experiment, a round-bottom flask or still pot is clamped. A few boiling stones are added to prevent bumping. Using a graduated cylinder, 30 milliliters of 1-to-1 acetone to 2-propanol, also known as isopropanol, is added to the flask. This is where the difference in the apparatus is between fractional and simple distillation. A coiled copper wire is added to the bottom of the Hempel column. This will be a makeshift plug. Ratchet rings are then added into the Hempel column to fill it. The copper wire will hold them in place. The Hempel column is then attached to the round bottom flask. The still head is then attached to the Hempel column. The West condenser is attached to the arm of the still head, followed by the vacuum adapter with blue Keck clips to hold them together. The water is also attached to the condenser. The first hose is attached to the faucet and to the bottom opening. The second hose is connected to the top opening of the condenser and into the drain. This will allow for maximum surface area for condensation. The thermometer adapter with the thermometer is then attached to the top of the still head. The thermometer is then adjusted so the bulb of the thermometer is at the entrance of the condenser. A graduated cylinder is then placed at the end of the condenser to collect the distillate. As you can see, the apparatus is very similar to simple distillation minus the Hempel column. The water is then turned on. Again, try not to turn the water on too high. You only need a small stream to come out of the drain hose. Pipe bed bulbs are attached to the opening of the Hempel column to maintain a temperature gradient, and the solution is allowed to heat up. Same as a simple distillation lab, record the temperature for every milliliter of distillate collected in a graduated cylinder. As the solution is being heated, know when to collect the 3 fractions. The fractions will be denoted by changing the graduated cylinder. The diagram should help you show you when to switch. The first fraction is to be collected while there is a relative steady temperature. When the temperature begins to increase, the second fraction is then collected. When the temperature begins to level out again, the third fraction is taken. When there is time to change the next fraction, simply change the graduated cylinder and continue collecting. No need to be in a major rush. You don't want to break any glassware. Missing a drop won't affect your overall results. Once you've collected all 3 fractions, you will then analyze them by GC. Using a micro syringe, take about 2 to 3 microliters of the fraction and prepare to insert it into the GC port. Click Go on the program and inject your sample. In about a minute, the peak should show up. Once done, click Stop and integrate the peaks. You want to repeat these steps for each fraction. Be sure to identify which is acetone and which is isopropanol, depending on the volatility of each. Once you've integrated the peaks, you can calculate the mole percent. Once you've calculated all the mole percents, analyze the data to see if simple distillation is a good method to separate acetone and isopropanol based on the mole percents of each fraction and the volumes of each fraction as well.